Hello everyone, myself Sahana studying in Sri Venkateswara College of Engineering in ISC 4 and I am here to explain the topic on correlation and coefficient. Firstly, the contents. Definition of correlation, definition of regression, types of correlation, types of regressions, formulas, examples and at last conclusion. The correlation and regression are two statistical method concepts or commonly that is used to analyze the relationship between the variables and it make the predications. Firstly, the correlation. The correlation measures the strength and direction of the linear relationship between the two or more variables and it does not imply for the causation but helps them identify if there is any consistent pattern between the variables. Nextly, the types of correlation. Pearson correlation. The Pearson correlation coefficient is the most common method to measure the correlation between two continuous variables and it ranges from -1 to +1. A positive value indicates a positive correlation, both variable that increases the together. A negative value that indicates a negative correlation means one variable will increases while the other will be decreases, and a value that is close to 0 that indicates weak or there is no correlation. Nextly, Spearman rank correlation. This method will measure the strength and direction of the monotonic relationship that is between the two variables. It is used when the variables are ordinal or the relationship is non-linear. Kendall's tau is nothing but it is a similar to Spearman rank correlation that is measures the strength of ordinal association between two variables. Nextly, regression. The regression is a statistical technique that is used to model the relationship between the independent variable and one or more independent variables. The goal of this regression analysis is to find the best fitting mathematical equation that will describe how the independent variables or affect the dependent variable. There are various types of regression, but the two main categories are simple linear regression. This is the type of regression that involves a single independent variable and a single dependent variable, and there is a relationship between them is assumed to be a linear. This equation for a simple linear regression model is of the form y is equals to mx plus b, where y is the dependent variable, x is the independent variable, where m is the slope and the rate that is changes of y with respect to x, and b is the y-intercept that is the value of y when x is 0. The multiple regression is a statistical technique that is used to explore the relationship between a dependent variable and two or more independent variables. It extends the idea of a simple linear regression which involves finding a linear relationship between a dependent variable and a single independent variable. In multiple regression, we have one independent variable and multiple independent variable. If the correlation coefficient is +1, it will indicate a perfect positive correlation, meaning that as only one variable that will increases and other variable also increases in a linear fashion. If the correlation coefficient is -1, it indicates a perfect negative correlation, meaning that as one variable that will increases and the other variable will decreases in a linear fashion. If the correlation coefficient is close to 0, it will indicate a weak or no relationship between the two variables. Next is list of formulas. The regression line of x on y is x minus x bar is equal to r into sigma x by sigma y into y minus y bar. If regression line is of y on x, then y minus y bar is equal to r of sigma y by sigma x into x minus x bar. Nextly, regression coefficient of x and y is r is equal to plus or minus, that is square root of coefficient of x into coefficient of y. Nextly, the correlation of coefficient is equal to, that is r equal to summation of x minus x bar into y minus y bar divided by n into x sigma x into sigma y. Example, find the correlation coefficient and regression line of y on x for the following data and estimate the value of y, that is when x is equal to 10. We know the formula for the correlation coefficient, that is summation xy by n into sigma x into sigma y, that is equal to summation of x minus x bar into y minus y bar divided by n into sigma x into sigma y. By using the correlation coefficient formula, we need to form the table such as x, small x, that is values are 1, 3, 4, 6, 8, 9, 11 and 14. By adding them we get summation of small x is equals to 56. Next is small y. The values are 1, 2, 4, 4, 5, 7, 8 and 9. And by adding them we get summation of small y is equals to 40. To find the capital X is equal to x minus small x minus x bar. To find the x bar we know the formula, that is summation of x by n, that is 56 by 8 is equals to 7. 1 minus 7 is minus 6, and we need to do for all the values such as we get minus 4, minus 3, minus 1, 1, 2, 4 and 7. To find the capital Y, that is equal to small y minus y bar. And to find the y bar we know summation of y by n, that is 40 by 8 is equals to 5. 1 minus 5 is equal to minus 4 and 2 minus 5 is minus 3, such as we need to do for all the values, and we get minus 1, 0, 2, 3 and 4. And we need to find the capital X square, and minus x whole square is equal to 36, minus 4 square is 16, minus 3 square is 9 and minus 1 square is 1, 1 square is 1 and 2 square is 4, 4 square is 16 and 7 square is 49. By adding the summation of the capital X square we get 132. And next is to find the capital Y square, and minus 4 whole square is 16, minus 3 square is 9, minus 1 square is 1 and 1, 0, 4, 9 and 16. And at last we get summation of minus y capital Y whole square is equals to 56. And at last we need to find capital X into capital Y. Minus 6 into minus 4 is plus 24. Minus 3 into minus 3. Minus 4 into minus 3 is 12. Minus 3 into minus 1 is 3. Minus 1 into minus 1 is 1. 1 into 0 is 0. 2 into 2 is 4. 4 into 3 is 12 and 7 4s are 28. And by adding them we get summation of capital X into capital Y is equal to 80. And we already find x bar, that is equal to 7, and sigma x square is equal to summation of capital X square by n, that is equal to 132 by 8, that is 16.5, and the square root of it is 4.06, which is sigma x. And we already find y bar, that is equal to 5, and we need to find sigma y square, that is equal to summation of capital Y square by n, that is 56 by 8 equal to 7, and the square root of 7 is 2.646, which is sigma y. And to find the correlation coefficient, that is R is equal to 84 by 8 into 4.06 into 2.646, and that is 0.977, which is correlation coefficient. And the question is only to find the regression on line of y on x, and The formula is y minus y bar is equals to r into sigma y by sigma x into x minus x bar at x is equal to 10. Therefore, y minus 5 is equal to 0.977, which is correlation coefficient, into sigma y is 2.646 by and sigma x is 4.06 into x is 10 minus and x bar is 7. Y minus 5 is equal to 0.977 into 0.652 into 3. At last we get y is equals to 6.91. At last is conclusion. In conclusion, the correlation and regression are powerful statistical techniques that is used to analyze the relationships between variables in a data set. They are essential tools in both descriptive and inferential statistics, helping researchers and analysts to understand and model the associations between different variables. At last, thank you everyone.